Alrighty, we are looking at the Pythagorean theorem today. And so this is something that's probably very familiar. We're not going to look specifically at the a squared plus b squared equals c squared and how we can use that. We're going to look more specifically at how we can apply the Pythagorean theorem. So that's what we're going to do today is we're going to apply the Pythagorean theorem to determine the kind of triangle we have. It's a pretty cool thing that we can do. The other thing that we're going to do kind of doesn't relate necessarily to the Pythagorean theorem, but it kind of lends itself well with this. We're going to determine what kind of triangle determine if we have a triangle. So that's what we're looking at. So the Pythagorean Inequality Theorem. So this is how we can apply the Pythagorean Theorem. Is that's basically saying that if A, B, and C represent three sides of a triangle, and C is the longest side of that triangle, then C squared is less than A squared plus B squared, then that triangle is going to be acute. But if c squared is greater than a squared plus b squared, then that triangle is going to be obtuse. So that's kind of how we're applying the Pythagorean theorem. And in this case here is the Pythagorean Inequality Theorem. So the Triangle Inequality Theorem is basically just saying the sum of any two sides of a triangle has to be greater than the length of a third. And so that's going to be that second part that we can see, do we have a triangle from our information? All right. So, Pythagorean Inequality Theorem. So it says determine the type of triangle from the given sides, 3, 5, and 5. So first off, it says that we need to, for the first step, figure out what our largest side is. So in this case here, I'm just going to say 5 is my largest side. I know I've got two sides of 5, but we're going to say 5 is my largest side. And then what we're going to do is we're going to plug it into that Pythagorean theorem. Now, when I say plug it into the Pythagorean theorem, it's a squared plus b squared equals c squared, but I'm going to leave that equals off for now. So we're just going to kind of leave it like this. So we're going to plug our numbers in. So we've got 3 squared plus 5 squared, and then we've got 5 squared over here. You're going to see why I do that here in just a second. So 3 squared is 9, 5 squared is 25, and then 5 squared here is 25. Well, when I add those together, I get 34, and then this is 25. Now, when we look at this, we can see 34 is definitely going to be a greater number. So 34 is bigger than 25. Well, when I come over here and look at it, if a squared plus b squared is going to be greater, or in this case, if c squared is less than a squared plus b squared, then that means that it's going to be an acute triangle. So that's how we can kind of use it. And I like leaving it in that Pythagorean theorem, but not putting any symbol in until you get to the end. That's just the way that I like to do it. If you guys have a better way to do it, then by all means do what works for you. All right, so let's keep doing this. So on this one here, we've got 3, 7, and 8. So again, determine the largest side. So that's going to be my largest side. And I'll actually switch it around so that way it matches this box here. So a squared plus b squared, and then we've got c squared. So we've got 8 squared, and then we've got 3 squared and 7 squared. Well, 3 squared is just 9, 7 squared is 49, and then 8 squared is 64. And so when we add those together, we get 58 and 64. Well, now we compare the quantities. Well, c squared is going to be greater. 64 is greater than 58. And when c squared is greater, then that means that the triangle is obtuse. So that's what we have there. All right. Next one here, 3, 4, 5. So again, first determine the largest side. So that's 5. So c squared, a squared plus b squared. And then what we're going to do is plug the values in. So we get 5 squared, which is just 25. We get 3 squared, which is 9, and then we get 4 squared, which is 16. And so when I add 9 and 16 together, I get 25. So those are going to be equal to each other, which means this is going to be a right triangle. And this actually, 3, 4, 5, is what's called a Pythagorean triple, because it's a nice, perfectly square sides that you have going on there. All right. Next, this is the Triangle Inequality Theorem. So it's basically just saying determine the largest side, which is 10 in this case here. And now we're going to add the two smaller sides together to see, do we have a triangle? So 10 is my largest side. 3 plus 7, when I add those together, I get 10. Now you might look at this and be like, oh, 10, 10, and 10. Well, there we go. But the problem is that it has to be greater than. 10 is equal to 10. It's not greater than that. So this is not a triangle. So that's what we've got going on there. And then the last one, so Triangle Inequality Theorem, again, determine the largest side. So we get 11 right here is my largest side. So 7 plus 9. Well, when I add those together, I get 16. And so since the 16 is greater than that, then we would say that, yes, this is a triangle. And then I could apply that Pythagorean Inequality Theorem to determine the type.